Hi all. Today we are going to discuss about a powder-based additive manufacturing process. This is coming under Unit 5 in additive manufacturing subject. Let's move on to the introduction about selective laser sintering. It is the one of the powder-based additive manufacturing process where powder is processed by using laser to the required product. Like SLS is the rapid prototyping process that builds model from a wide variety of materials, so like metal powders, polymers, like that. The building media of SLS comes in powder form, as you know that already I told that it's a working medium is the powder form, right? Which is the fused together by the carbon dioxide laser. Carbon dioxide laser, which is used to melt the metal powder to the particular form. Okay, so let's move on to the its operation. So this is the this picture represents the laser which sinter the powder. Like here in the right side diagram, you can clearly see that some of the metal powders are absorbed by the laser and some of the scatter and some of the reflection. Only absorption metal powder only solidified, that is fused to the fused as metal. Okay, so others are scattered or removed. These are the these are called unsintered powders. Okay, so the later the unsintered powders collected by the collecting mechanism, and it will use it for the further process. And this is the typical setup of the selective laser sintering process. This is the roller which is used to uh, move the powder from compartment 1 to compartment 2, and here is the optical setup. Here is the laser producing source which ejects the laser source, and this mirror will direct in the compartment 2. This movement will be controlled by the computer, which already has the STL data. So STL data means standard tessellation language format. In previous we actually created on three dimensional object, which is the application one. That 3D modeling is created by any three-dimensional software. Later it converted into STL format, and later it transforms into the system, which the language understand by the computer. That is the format called STL format. Okay, so the STL data is already uploaded in the system. Therefore, the operation is controlled by the computer by its STL formats. Okay, so the STL formats later the entire product will be sliced together, and the individual slices are fused one by one. Okay, so additive manufacturing, you know that additive manufacturing is the layer by layer manufacturing process. So like that, only in this process we use the powder as a working medium. Okay, so the metal powder is mm, uh, filled by using this roller from compartment 1 to compartment 2. After that, the unsintered powder which is moved to the compartment 3. This is the unsintered powder collection compartment. Here you can clearly see that the arrow mark, this one is upward. Here the metal powder is uh, projected upwards. This the upward dimension is the layer thickness, which will already given by the slicing process. Okay, so here the powder will come into the compartment. The laser will absorbs the metal powder, and the metal powder got fused. After that, the fused is the solidified as a layer. So let's move on to the next one. Here is the clear pictorial view of the SLS diagram. As already told that the roller powder compartment, here the working compartment, here the unsintered powder compartment, is the laser source. As you all know, is the carbon dioxide laser used as a laser source. Okay, so powder layering, etc. Here, these are the 3D models which is prepared by using SLS process. You can clearly see the diagrams. After that, these are the commonly used materials in SLS process, which is aluminum filled, some aluminum particles, impact resin, nylon. These is the their scientific name, Lyroform PA, glass filled nylon, okay, carbon fiber filled nylon. These are the raw materials for SLS process. And this is the entire system. The entire system is nothing look like a on CNC operating machine, right? Here is the computer which is controlled which is controlled the entire machine is controlled by the computer. Here the CAD data, STL data will be feed. Okay, these are the process parameters. First one is part bed temperature, second is layer thickness, laser power, laser scan speed, and energy density. We can see one by one in later slides. Okay, this is the bed temperature is the important parameter. In case of non-heating in the bed temperature, did not fused in the bed. Actually, the bed is maintained by some temperature. Okay, so after that, layer thickness, already I told that the thickness matters. It will helps the machine for a slicing process. Okay, thickness of each layer during the SLS process is the layer thickness. Next one is laser power. It's around a 10.6 micrometer. So next one, energy density. How much energy it needs from the SLS system. It can be calculated by using this formula. ED is equal to LP. Energy density is equal to laser power. After that, the beam speed and spacing, distance, etc. This is the formula used to calculate the energy density. And these are the advantages of this process. Um, as you know that it's an automated process. There is no human intervention needed. The method is extended to the provide direction fabrication methods. Ceramic object also can use it to use here. SLS are fast, economical, and durable one. And these are some advantages. Thank you. We will meet again in the further slides. Thank you.